In this video, we're going to discuss single slit tutorial. A monochromatic light of wavelength 500 nanometer passes through a single slit experiment of width 0.25 millimeters. So this one is our lambda. This is slit width. So this is our A. A screen is placed 2 meters away. This is our D. Calculate the distance of the first minimum from the central maximum. So for question A, we are looking for the first minimum. So the order is 1. We just straight away going to use y1 equals to m lambda d over a. We substitute the values. We get 4 millimeters. Next is width of the central maximum. We can see that width for the central maximum is double of the y1. So based on that, we're going to use w equals to 2y1. We substitute, the answer is 8 millimeters. Question 2. A blue monochromatic light of wavelength 550 nanometers passes through a narrow slit of a width 0.25 millimeters. So this is our lambda, this is our A, so this is our D. Calculate the distance from a central maximum to the second maxima. Because we're dealing with maxima, we're going to use ym equals to m plus half times lambda d over A. We substitute the values. Answer is 9.9 millimeters. Question number 3. A single slit of width 0.2 millimeters, this is our A, is illuminated by a monochromatic light and placed 2 meters from the screen. A slit of first illuminated with red light of lambda, this one, and violet of this lambda. Calculate the difference in the width of the central maximum. So basically, dia nak tengok beza antara width red dengan width violet. We put red light dan juga violet light because this is a maximum. Width for the red is 2 lambda d over A, and the answer is 13 millimeters. For the violet, and the answer is 8.4 millimeters. Together, because we are looking for the difference, hence, the difference in the width is 4.6 millimeters. Now, let's go to diffraction grating tutorial. Question number 1. A diffraction grating has 600 lines. So, this is our N per millimeter. Now, millimeter is L. A monochromatic light of lambda 500 nanometers passes through it. Calculate the angle of the second order maximum. The first thing we have to do is to get our grating spacing. D equals to L over N. L is 1 millimeters divided by 600 lines. And the answer is 1.67 times 10 to the power of negative 6 meters. And then from there, we're going to use sine theta equals to m lambda over D. The order is 2. Lambda is 500 nanometers. Grating spacing that we got just now. So the answer is 37 degrees. Yang ni kena shift sign. Next question. A laser beam with wavelength 580 nanometers shines perpendicularly onto a diffraction grating marks 400 line per millimeter. On a screen, several bright spots appear symmetrically about the central bright spot. Calculate how many bright spots can be seen in total. Bukan setakat nak order, tapi kita nak cari berapa jumlah spot yang kita nampak. For that, kita cari dulu grating spacing. 1 millimeters bagi dengan 400 line. 2.5 times 10 to the power of negative 6 meters. Sekarang kita nak cari order dulu berapa yang paling kecil yang kita boleh nampak. Masukkan nilai D dan juga lambda. Order sepatutnya kurang daripada 5.21. Order kita yang paling banyak ialah 5. Sebab M mestilah lagi kecil daripada D over lambda. Tak boleh pergi 6. So total bright maxima, X equals to 2M plus 1. The answer is 11 maxima that we can observe. So kita akan observe 1 dekat tengah-tengah. And then ada 5 dekat sebelah kiri. Dan lagi 5 dekat sebelah kanan.